Let's get started with some brief introductions, and maybe we'll start at the far end with Keith Cherkauer. So again, if you'll introduce yourself and just a little bit about your interests based on discovery, learning, engagement.
Okay. I'm Keith Cherkauer. I'm an associate professor in agricultural and biological engineering. My interests are in making observations of the physical world using field sensors and remote sensing, using those to develop improved algorithms for hydrology models so that I can look at or better quantify how climate and land use changes will affect water availability in the future.
Dr. Gitau.
I'm Margaret Gitau, Associate Professor in Agricultural and Biological Engineering. My research focus is water quality. I do a lot of hydrologic and water quality model assess and trends and impacts of affecting factors. That's particularly climate, land use, and land management. And I also develop computer-based tools for improved water decision-making and management. My current work is focused in the Western Lake Erie Basin. That's where there's a lot of water quality problems that have been experienced lately, specifically related to phosphorus. I'm also working on extending this work to the Eastern African region. I use a whole different suite of models depending on project objectives, and therefore my group, we have a good experience with state-of-the-art models, several state-of-the-art models, including one which we developed ourselves.
Thank you. Hubo?
My name is Hubo Kai. I'm an associate professor of civil and construction engineering. My main area is infrastructure engineering and the use of sensing systems to detect, map, and visualize underground utilities and pipes. That part relates to water quality. And the recent efforts have been using ground penetrating radar to visualize underground pipe in real time. So you get to know where your pipes are and what their conditions are. And my connection to the water quality part is that in my view, water quality, water resource management, it's just not looking at the source itself as well, but we also need to pay attention to the pipes that carry waters from its source place to end users. So that's the part I'm focusing on.
Thank you. Dennis.
I'm Dennison. I'm a professor of civil engineering. I'm basically in the hydraulics area. I was remembering Professor Maidment's comments about the three types of discovery. I aspire, I can't claim, but I aspire to be somewhat like a Newton, and also like a Pasteur, not necessarily like a Darwin. I'm interested in experimental studies, particularly in the lab. That's my Pasteur-like aspect. But I'm also interested in understanding the mechanics of what I see in the lab. I'm interested in sediment transport, open channel flows, river engineering, stream restoration, so all those aspects.
So if you're wondering what Dennis is talking about and you missed the lecture yesterday, it is on video. And Marcia, I think you indicated that would get shared in the not too distant future, so you'll certainly want to look back at that, and that'll provide the context for Dennis's comments. So certainly last but not least, by any means, David.
Well, thank you, Dr. Engel. I have to say I have something of a hybrid personality here because I'm originally from New Zealand and my first degree is in agricultural engineering. So I started off in irrigation, okay, there you go, soil and water and things like that. And then in my graduate degrees at the University of Illinois, I did civil engineering. So I've gone over to the other side to the hydrology and water resources. So I'm a surface water hydrologist and I've dealt with geographic information systems and water resources and most recently with the National Water Model, the development of a simulation model for water for the whole country with the National Weather Service.
Thank you. So we will have opportunities for questions. I've got 3 pages of questions, so while you're thinking about questions, let me maybe pick a question that each of the panel might respond to. Looks like we have a microphone to capture it if you would like to ask it verbally. And again, you have note cards if you would like to write these down. So our colleagues, as I said, submitted some questions. And let me maybe start with one of the interesting ones, at least to me on here. And there were certainly many interesting ones. But and we can maybe, again, come down the line here. So in your opinion, are the greatest water security challenges going to be political or technological? So how's that for an easy starting question? So Keith, do you want to start? Let's come this way and while people are thinking of their questions.
Oh, goodness. I'll have to come up with an explanation. I mean, I think politically is going to be a big challenge. I think we're already seeing growth in conflict due to water scarcity. There are lots of parts of the world, Middle East in particular, where water is very scarce, and so far things have been fairly stable, but as climate variability increases, I think the political situation is not good, and that's likely to increase the chance of major problems.
Margaret, your thoughts?
I think it's going to be both, because definitely countries have to think about how they're going to manage their waters in the future, but also the fact that waters do not know boundaries, state boundaries, and that they cross boundary lines. And a lot of times the conflicts you're seeing are interstate conflicts or inter-country conflicts, and those are things that will need to be addressed in the future. Technologically, we have some other issues that we need to think about, like population growth. With 9 billion population expected in 2050, we're going to need some technological advancement. With climate change, then we need to think about how we manage our resources, because the way we do this is not compatible with a different climate in the future.
So, in my view, of course, this is definitely going to be both political and technical. I'm just getting down to the community level when we talk about energy independent communities, connected smart communities. And I think technology plays an extremely important role in terms of monitoring how we use the water and how much we're using it, where the water comes from, how the conditions of water is. So that's my couple inputs.
Dennis, your thoughts?
I'm inclined to punt on this one, but I'll perhaps throw out one idea, and that's the thought that perhaps through technology we can avoid the tougher, or at least postpone the toughest the political decisions.
So David, in your talk yesterday, it was fascinating to hear about your efforts involving the recent hurricane in Houston, and certainly that had both political and technology kinds of issues in it. So looking very forward to your thoughts on this question.
Well, let me just answer in that context then. So, we had the nation's largest storm that has ever occurred in Hurricane Harvey in southeast Texas just a few months ago, and I served in the State Operations Center to help with the emergency response to that. I would say that the political intentions were clear. I mean, we had the governor there. They deployed the entire National Guard. We want to save lives and property. We want to save, and especially during the hurricane, we want to save lives. So I would say at that point, the chief challenges were technological, actually. The intentions were there, right? I mean, the desire was there. The question is how to translate desire into reality. And the knowledge, there was a huge knowledge gap between what we knew and what we needed to know to be able to bring resources in to help such a severely impacted area. So, I acknowledge the comments of the colleagues here who say that political constraints can be crucial, and often they can. But I would say in that circumstance, the technology constraints were greater than the political ones.
So can you think of an example from your experience where the political may have been the bigger constraints, and could you share that?
Well, so that's a good question. So when I first started my career, when we both were young together, a long time ago.
We're still young.
Well, yeah. I was the drainage engineer for a small community, right? So I was the person who permitted new commercial buildings and subdivisions for compliance with the city's drainage ordinances. And the city administration wanted to have water quality controls as well. So this was 1980s, right? And so their aspiration was, we're going to protect our underground aquifers from drainage from the surface water systems from pollution. But I did not know how to do that. So it wasn't it was sort of like a political aspiration that had gotten ahead of technical knowledge. And in fact, I quit. I said, hey, you want that? I'm not your person, right? Because you're asking me to be an engineer for something that I don't understand. You're saying, I want to purify this aquifer system. We didn't have the design methodologies and all the work that's been done since that time to do that. So I think sometimes political, it's not a constraint, it can actually be a desire to do something that we simply don't know how to accomplish at the time.
Great. Do we have a question, or should I move on to the next one? All right. I certainly have more. So one that change pace a bit. So what general advice would you offer to the engineers and scientists that are here today, especially our graduate students and maybe some undergraduate students that are seeking a career in the water resources and related areas? So again, maybe if each of the panel might respond quickly to that question. So
advice that would be given?
Yes. Advice for our students today.
What? I guess learn to be flexible. Right? We can't stick with the rigorous methods that we necessarily did designs with in the past. We need to be prepared to deal with extremes that are unexpected. And that means you can't plan for all of them, but you have to be prepared to respond to them. Right? We can't predict a Hurricane Harvey is going to hit, but when it does, we need to be ready to do something about it.
I'd say, think broadly, and seek to engage with a broader group of people, whether it's managers or scientists and all. Because if you talk to different people, different professions see water resource challenges differently, whether it's economists, engineers, social scientists and all. And really, water resources are not a problem for one particular discipline to solve. It's an interdisciplinary problem. So the more you engage with interdisciplinary groups, the more likely you are going to have an impact on water resources development going into the future.
Well, my advice would be taking human factor into consideration, because I think for students, here at Purdue, you're going to develop very strong and solid engineering backgrounds and knowledge in that part. My personal experience when working on an NEPDS program for North Carolina Department of Transportation, the biggest challenge is not the technology itself. The biggest challenge is actually talk to the stakeholders, especially those people or residents living in areas that there are some encroachments going on, there are some water pollution issues you identify over there. Bring them to the openness and make the process transparent and get them engaged. That part, one of our panelists said, you got to be flexible and also deal with the human subjects.
I think all of those suggestions are certainly desirable. I would perhaps add that one should perhaps also have a certain humility as to what one can achieve, especially technologically wise. Sometimes we go out of the university thinking that we can solve all of the problems all the time, and that may not necessarily be true.
So I would like to answer the question in a little bit more general way. I'm going on Monday to the University of Canterbury, where I got my first degree, and I entered as a freshman 50 years ago, to 1968. So I've often thought, what would I say to myself if I could speak to myself through the years? What could I say to my young self from what I now know compared with what I knew then? And I would say there are three things. The first is educate yourself as much as you can. I mean, to the highest level that you can. I mean, that's what you're here doing, right? The second is have confidence in yourself. Have confidence in your judgment. Believe in yourself. When I was a grad student, I didn't really believe in myself. I didn't have much confidence in myself. But gradually, through the years, the confidence increased. But yeah, believe in yourself. And the third is dream the impossible dream. Because I think if I've got a lesson out of my life that I've learned over the years is that dreams really do come true.
So I think the gist of the question is, given uncertainty about many, many things in the future, how should we be thinking about addressing those issues? And I think also in the context of students preparing themselves for future opportunities, how do they best prepare to deal with this great deal of uncertainty on many fronts that we face? Who would like to respond to that one? I'm sure you each have some thoughts.
I would start. I think there's a couple. It's a challenging question, but I think there's different joint strategy. I mean, some of it is repairing some of the damage we've done to the natural systems. The natural systems are are capable of handling more variability than some of our technological starts, certainly how we've been building our infrastructure. So I think that is one component of it, going back into the landscape and putting in or returning the wetlands and other aspects, the barrier islands and those things that we can in fact fix. And then because we can't restore everything to pre-habitation, right? I think we have to invest in things like smart technology that can be more responsive. And there are, I think, plenty of cases out there where people have started doing that, and I think that building in sensors, building in systems that can be modified to deal with whatever the current crisis is, and so building that flexibility into our infrastructure has to be part of what we're doing.
Someone else? Margaret?
Well, I say the worst thing we can do is do nothing because we don't have the information. But we have at this point sufficient information to say that we know some things. For example, with respect to climate, that we're expecting the storms to be more severe and the more severe storms to come more frequently. So we don't really know 100% that how it's going to happen, but we know that something like that is coming. So would we design solutions at this point, be prepared, and then find out we didn't need to, better than saying that we don't really have enough information and therefore we can't be prepared. So kind of looking at what information we have and preparing in advance for whatever the eventuality may be.
So Hubo, thoughts from an infrastructure standpoint?
Yes, that's a great question. I would say, I think from technology perspective, from a science and engineering perspective, we have lots of tools available. You can do risk assessment, you can do statistical modeling, looking at the expected value, things like those. So one challenge I found or I faced when I deal with the underground utility pipes is that there are so many uncertainties. You just don't know. You look at the signal coming back, there are millions of possibilities that contribute to that specific signal signature. So how do we deal with that? So one approach we took about it is from technology perspective is we call that a multi-sensory system and the data fusion process rather than relying on the single system. So I think being an engineer, I always look at this underground utility mapping as an engineering problem, and my way of solving it is always thinking about how can I make my system more robust. And the other thing, one of our panelists already mentioned, is that when you develop your system, be prepared. Be prepared for the worst situation. You always have a plan B, and also make the system much more flexible. Again, taking my experiences that when we scan underground the pipes, the ideal situation is that we would like to go perpendicular to for the path and the underground pipe to be perpendicular to each other. But that's not possible, right, in reality, because you really don't know where the pipes are. So the question becomes how you can actually adjust your system in real time as you receive partial signals, and then adjust your travel path or the trajectory accordingly.
Thank you. Dennis, any thoughts?
Well, a couple of thoughts. One is that so frequently we have in our engineering projects a very small viewpoint or very localized viewpoint. And for a kind of resilient system, you perhaps need a larger viewpoint or a broader viewpoint. And I guess the question is, how can we make individual decisions perhaps more responsive to a larger system?
David?
I'd like to refer back to 2011. I don't know if you remember this, but we had a severe drought in 2011 in Texas. We lost 100 cubic kilometers of water. And that's about half of Lake Erie, for example. Just got up and left. And in the spring of 2012, the water system was weak. But that wasn't the key impact. Everyone understood that their water system was threatened. What I didn't understand was that our power system was under threat as well. So Texas is in something called Aircut, which stands for Electricity Reliability Council of Texas, and we're isolated from the rest of the country for some private enterprise reason. I don't know why. But we have about 110 power plants, and of those, about 10 were threatened by low water conditions and high water temperatures. Sufficiently so that Aircut started to issue public warnings about rolling blackouts. You know, Houston's out for 3 hours, Dallas is dark for 3 hours. I mean, this is something you just don't even think about in a modern society, that, you know, the water system can bring down your power system. So I went down to Aircut and I started making a few inquiries, and I said, well, what are you guys doing about that? He said, we've done a survey of our members and they're feeling good. Oh my God. This is our state leadership, right? This is our state leadership. We're facing a crisis here. They're doing a survey of the members and they're feeling good. And I was like looking down into an abyss, and I realized there's nothing. We got no leadership here. Now, I was really frightened. I was truly frightened. And in all the years I've been a faculty member, I've never been as frightened as I was on that day, realizing that, you know, we're drifting. You know, we've lost power and we're drifting. Our state's got no leadership here. And what we needed to know was, you know, how much flow to be expected and what would be the temperature of the water. And then you can make rational judgments about what was going to be the impact on the power system and start to figure out what to do. And there was a gap there. We just didn't have that knowledge at that time. You know, now we have this national water model, so at least we can get at the flows. But yeah, I would say in that circumstance, having better knowledge than existed at the time would have been something that we could have used.
So David, that sounds like a political failure, to sort of offer another example from the earlier question. So what happened in that case?
So what happened was the summer of 2012 wasn't as severe as the summer of 2011 had been. And if it had been, our power system would have gone down, for sure. Yeah, for sure. So we sort of limped along, right? We limped along, and at the time we had about 2% more power supply than we had demand. And the demand had been really high in the summer of 11, but we had enough water to sort of ward it off. But by 12, that water had gone away. So fortunately, the summer wasn't as hot, therefore the demand didn't go up as much. So even though the water system was frail, they sort of eked it out. And that kept going for several years afterwards, and it was only in 15, when we had all the floods, that suddenly the water all came back. We got kind of bailed out by nature, you could say.
Great. Other questions, or should I keep going for my list?
Let me perhaps ask, respond to
Sure, thanks.
Professor Maidment's comments. Let's assume that you did have perfect knowledge of sensing and all that that you wanted. Would that have avoided the political decisions? I mean, in the end, the political decisions could just as well have been irrational.
So the trick is that the power system is in private hands. It's all private enterprise. So that all private companies, and they keep their decisions to themselves. So you've got the two pieces. The water system is public, the power system is private. So at least the public system, you can put the information underneath the private system and say, this is what you can anticipate. Now, what goes on beyond that and what decisions that they make, they're private entities. So they're going to make the decision that's best for them. Now, having said that, if we reached a crisis, the governor and our political leadership would have had some leverage. So, I can't figure how that would all have played out. I don't know enough about the power world to know that. It was a consequence of previous political decisions to introduce a competitive bidding in our power system that led us to be isolated as we are. And whether the vulnerability of our state's power system to this kind of thing was even considered at the time, probably it wasn't. It was just one of these things about, if we have a competitive bidding for power supply, we can reduce the cost to the consumers and get, sort of squeeze out more out of our system. I think that was the motivation for it. But it was a scary moment, for sure. It was.
So David, that was 6 years ago. Yesterday you talked about the national water model. So how might that play a role in a case like this if it were to occur again?
Yeah, so what I was trying then to do was to say, look, if we had a model that could simulate the flow in all the streams and rivers, and it's a surface water supply problem because the power plants draw from cooling water systems, and then we could have said, what the flow would be or what the level would be in this lake that you're drawing water from. And even more important was what the water temperature is, because water temperature affects the efficiency of power plants. So we would have had a more rational approach to be able to solve the problem. And I'm really happy that now we do that. And there's kind of an object lesson in how that came about. So I was appealing to our state leadership to do that for our state, but we just didn't have the heft within Texas to pull that off, right? Or at least they didn't have the willpower, or I don't know, nobody had enough gumption. I talked with the chief of staff of our governor and laid it all out what I thought, and he said, how will this affect economic development? Okay. How will this affect economic development? Okay, whatever, I give up, But what happened was the federal government took the initiative. So right from the top in Washington. So I hear a lot of talk about, Washington's dysfunctional, they're all fighting with each other, the whole thing's a pile of not worth it. But my experience has been that there is visionary leadership in Washington, and that people do pull together, and that they do have larger aspirations for the country, and the federal government is the entity that has the heft to pull these things off, and they have. So I would say the lesson that I learned out of this is that this wasn't a problem that Texas had the will to solve by itself. It had to be done at the national level.
Great. Rush.
This is probably targeted at David, but can you kind of so I was impressed yesterday in the seminar when you said water anymore is like weather. Forecasting, sense of forecasting, at a continental scale. So I was going to ask you, you heard the weather forecast and said 30% probability of rain today. Would you carry your umbrella? Or should I do the same?
So I'm not sure what the default probabilities are for Indiana, but the default probability in Texas for rain on any day is 20%. So you'll never hear below 20%, right? Yeah. So you have to make a judgment on the differential from the normal to the current value. So 30%, yeah, I'd say I have an umbrella in my bag. Yeah, I would say that's true. The larger question is there confidence in our water forecasting, right? And so the conclusion I reached after watching this in Harvey was that the forecast of water is dependent on the forecast of rain, and that's a very uncertain quantity. And even if you forecast the rain with the volume correct, maybe it changes in spatial distribution from one atmospheric realization to the next. So really, you're making a forecast on top of a forecast. And so you've got additional uncertainty because the thing that you're trying, that's the driver, is itself really uncertain. So that makes, it's really only, we can only do things by percentages. I don't think, a single value forecast like I was showing yesterday, no, really we should have ensembles and all this, what we're doing.
Anyone else care to follow up on any of that? So I guess, just sort of maybe following on that, so if we now, we have weather forecasts, we have water forecasts, what's the next forecast that would logically build on that potentially? Do you see something that is out there as a aspirational kind of goal that builds on that?
I guess on top of that, water quality would be something we'd want to know on top of that. Right, and it just kind of, right, after river flow, you get, right, the power companies can use that to do their estimates, the irrigation companies can do estimates. So it kind of cascades as you move through that system, but we do have to narrow the uncertainty on that. So there's uncertainty in whether or not it will rain and where it will rain, but up here we also have to add in where does it snow, when does the snow melt. We don't do a very good job at even measuring snow. So there's lots of uncertainty that still has to be addressed.
So plenty of opportunities for our students in the crowd
throughout
their careers.
It's not going to be solved anytime soon.
Others before David maybe follows up on that one?
I would add you probably have to consider uncertainty in the demand side as well. For example, in the summertime, how much water you're going to use, and what's the effect of certain policies like alternated days for watering your garden and things like that. So you have to keep those into consideration.
So demand forecast maybe is on the horizon. Okay, good.
Yeah.
Another aspect is of course, I guess we can best forecast, and best meaning poorly, but we can best forecast when we have, let's say, current data. But if we wanted to change things, how can you forecast things that you're going to change policy on?
It's a tough one.
I would say if you look into the future, into the lifetime of you guys as your professional lives, I think drought is going to get solved. I don't think drought is an unsolvable problem. I just think it's right now it's an unsolved problem, because those 100 cubic kilometers that we lost, well, we detected that they were gone. We didn't know where they're gone. But better measurement over time, yep, we could track that down. We could start to track how water moves across the world. The measurement system that's available is called GRACE, which stands for Gravity Recovery and Climate Experiment. And the GRACE 2 mission is going to be launched in April, which is a follow-on from the first mission that was launched in 2003. And there are two satellites that are 220 kilometers apart, and the distance between them is measured to 2 microns. And as they fly around the Earth and have a higher gravity strength, then the satellites come together, and as you have lower gravity strength, they go apart. And that is sufficient to measure the movement of water, of large masses of water. That's how we know how much water that we lost. And the new system is going to be more precise than the one that went before. Hopefully you can do this over smaller areas than what we did in the past. So I think measurement systems are going to improve in the future to the point that the tracking of these large volumes of water around the Earth will be known, and that they can then investigate the forces that made that happen and understand when droughts are going to end and when they're going to start and what's going to happen. Because right now that's, we just look at it and say, we have no idea. But I think in the next 50 years and the next careers that you're going to go through, I think that's going to get figured out.
So once that's in place, then one can begin to design to mitigate these.
Yes, exactly, and anticipate how long you're going to have to withstand it, right?
Okay.
I mean, the big thing with drought is you just have no clue how long it's going to last for.
Great. I think we had a question in the back.
Going off of you're wanting to figure out how to predict different things, would you say the future would be in geoengineering, engineering the weather climate to kind of normalize it? Would you say it would be creating an AI system to dynamically think and figure out these drought patterns?
Can you repeat the question?
Yeah, we're getting a lot of fan up
There's
this
a lot
way, so if you
lower.
could speak louder would be helpful.
So my question is we're trying to make all these predictions. Would you say that the future would be to try to engineer the weather and the environment to normalize it so then you can make an easy prediction, or to create a technological system that's using AI, it's artificial intelligence, to then go in and find all the different areas, think ahead of time, and then predict the droughts, what possibilities?
Someone care to respond?
I guess engineering controlling the climate. There are certainly people who would advocate for that. I have, I guess, ethical issues with that, in that we're already experimenting with climate and don't, we have no backup if we mess something up. So I think, and I don't know, it's a big world and lots of people and lots of different opinions. So there may be some places where they try to engineer climate. I think there's a lot more that will be more adaptation. It might be more to do with smart networks, but also about rethinking how we use the resources that we have. I think there will be a lot more reuse. There is, really no reason that a city like Las Vegas couldn't reuse what comes out of the water treatment systems, and then all they would need on an annual basis is to replenish what has been lost from the system. And if more and more communities start doing that, you have we're removing more of that water from the environment on an annual basis, so there's more of it to share. There are, but it comes into technology and politics. The Mexico City area is looking at allowing, and there's, I will say that there are a lot of people doing different studies and analysis, but one of the things I was told when I was there is they were looking at allowing the rain that falls in the mountains to flow all the way down to the city. Instead, right now it is pulled out and used for irrigation, and then the irrigation water returns get to the city, and so they get very warm, very nutrient-rich water that they have to treat before the city can use it. So they're looking at reversing that and allowing the fresh water to flow down to the city, and then when the city is done with the water, pumping it back up and using it for the crops, and that means that river flow should increase. So changes can be done, right? I think technology will have to have a lot of that, but there's also, there's political issues. That the Mexico City is all inside one country, right? We still don't allow much water that goes to flow the Colorado River all the way down into Mexico, right? Two countries that should, in theory, get along, and we don't share particularly well.
So Margaret, thoughts?
Yeah, I think any time we think about changing something, we need to be aware of what else will change in response to the changes. So it's not just engineering the weather and we're done. What else is changing? What else is going to respond to that? What kind of responses would those be, and how would they impact us? And a lot of times those changes, it's hard to predict them into the, going forward. It may take time before a system responds. So I also have issues with that and engineering the weather. But maybe thinking about more real-time sensor networks. If we knew in real time what's going on, we're able to make decisions better. And I think with the infrastructure we have now, that's not impossible. That we can, it's something that can be done. That if everything is relayed to a central database and then broadcast, that anybody can know what's going on wherever it is they want to be or to do, then they're better able to make decisions.
Hubo, thoughts?
Yeah, I would add in is that I don't think AI systems and engineering the weather, they are in total conflict. They can actually coexist in a way that both contribute to solving the problem. My thought is that, well, first of all, you want to think about in a much system of systems approach. And the second, thinking about the AI systems, that really relies on a lot of data information. Broadly speaking, AI systems, they try to mimic the way human beings think and learn from their past rules or lessons and experience as well. So it's a self-learning process. In the future, if you really think about the future, I think it's going to be a long time coexistence of machine and human decision makers and the engineering principles all working together. Yeah. So it's not just the black and the white, you go one and total against the other one.
So Dennis, anything to add to that?
Well, just to think about one question I always have about information and information systems is, do we have the right information? I'm not quite sure anybody knows that with regards to even things like weather and perhaps even droughts. And of course, quality of information. Is it a lot of noise or is it really information? Even if we had, let's say, perfect information now, would we be able to predict with certainty what happens in the next hour, the next year? Just some thoughts.
Yes. David?
Earlier in my career, I investigated expert systems and artificial intelligence to some degree. In fact, I did a GIS, an expert system bridge at one time, using rule-based systems. But I came to the conclusion that I'm more comfortable with being able to explain why we're doing something. And I feel like if we hedge that in a black box, which is figuring its own way out somehow, I don't understand how it reached its conclusion. And so I don't know how much confidence I can have in that conclusion. So I would prefer that we resolved our conclusions with rational processes. And I guess I'm speaking as an engineer here. I don't want to have faith in a black box that I don't understand how it works.
Good, thank you. Let me ask maybe energy.
My question is in the context of groundwater withdrawal for irrigation, for food security around the globe. When I look at groundwater decline globally, and it's just not a developing country problem, but a problem here in the US and many other developed countries too. It's very concerning, and scientifically, there has been a lot that has been said on why groundwater table is declining in these agricultural dominated ecosystems, what needs to be done. But yet, I see very little progress being made. What is missing? What needs to be done?
I suspect each of you have an opinion.
By here, you mean in the U.S.? You mean, or just in general? But
I mean, it's a problem in the U.S. It's a problem in developing countries.
no, it is a problem everywhere. I mean, some of it is if we get back to politics, it's laws and regulations, right? Indiana is completely reactive, so you can file very easily to put in a new groundwater well, significant water withdrawal facility, file a little bit of paperwork, you do an annual report on how much you've used it, and you can do whatever you want with that well until you cause trouble for your neighbors, at which point they can come and ask you to pay off your neighbors, basically, do something, dig their wells deeper, provide them with bottled water, whatever it is. And in a situation like that, there is no motivation to do planning on where wells go, how you operate them in efficient manners. And so clearly in this case, the driver there is no driver to be proactive about it. You keep drilling until you cause somebody harm. I think that the legal framework across the U.S. is a hodgepodge of things. It's somewhat more established on the surface water side, and yet it's still not consistent in any way. And then you get out of the U.S. and again, who owns that water and who's responsible for using it in a responsible fashion? I think that's a big part of the problem.
I think that maybe the way we look at groundwater is what needs also to be looked at. So for example, we acknowledge that surface waters will cross boundaries, and we see those conflicts there between states or countries where the surface waters are crossing boundaries, but groundwaters too. And we look at aquifers, they do. We're not seeing them, so maybe it's not that evident, but they do cross boundaries the same way. They are not refined. So you talk about abstracting water and affecting the neighbor, abstracting water and affecting the next state or the next country, and that is something that maybe is not acknowledged or looked into that would make a difference in how groundwaters are managed.
An infrastructure perspective maybe on this?
Well, I would think it's actually more of thinking about the water resource as an asset versus it's a free, resource to everybody. So speaking of Indiana, you dig a hole, you get some water out, and does the city really care about where you dig it, or how much you use, right? So under that kind of situation, also think about monthly we pay our utility bills, we pay our water bills. What are we paying for? We are not paying for the water itself, right? We are paying for all the added value by the water treatment plant, by the water companies and the piping system, etc. I think, not exactly from the infrastructure perspective, but I'm thinking about is that we should change our way of thinking about the water resource. Is it a free resource to everybody? We take it for granted that we have access to water. We don't have to pay for it, or it is more of something else. It's actually a privileged resource, and everybody has to basically, let's put it this way, have to put a price tag on the water itself.
Dennis, any groundwater thoughts?
I'm out of my element here, but I'll try to offer an economic perspective. I sometimes like to think of the model of the invisible hand, where individual actors somehow, through their individual actions, come up to some optimum. Even though they may act for their own self-interest, they come up to some common general optimum. And again, I come back to the idea of how do we get that idea into water resources and water resources management.
So David, I know you've spent most of your career focused on surface water hydrology, so some thoughts around groundwater.
So I was thinking, we've had this situation in the high plains of Texas, right? There's a chunk of the Ogallala Aquifer, about 100 feet thick, still goes all the way down. In Nebraska, it's about 1,000 feet thick. And so in the 1960s, California had a huge water plan to move water south to basically establish Los Angeles and San Diego. And Texas was inspired to do a similar thing. They had Texas water plan to move water to the high plains to save the irrigated agriculture that was being threatened by depleted levels in the Ogallala Aquifer. And the voters voted it down. They decided they didn't want to move, and it's basically about a 3,000 foot lift because the West Texas is high up compared to the East Texas where the water is. So instead of having these big pipelines out to West Texas to save irrigated agriculture, the voters said no. And what happened over the time was that the amount of irrigated agriculture diminished as the depth to groundwater increased, and gradually attained an equilibrium where the people who were really willing to pay for deep pumping continued to do so, and others converted back to rain-fed agriculture again. So it hasn't been a disaster for the high plains that we had an aquifer threatened. It just took decades to establish the equilibrium between the supply and demand there.
Another question? Yes?
Dr. Lynn brought up the invisible hand, but doesn't that sort of rely on people understanding the value of, or what's there, what exists of the resource, which is also why, like we almost brought the Atlantic cod to extinction, and the pigeons that were hunted almost to extinction, because people didn't really understand what part of the resource still existed, and couldn't that happen for groundwater also, that people don't really understand how much there is, and so they don't value it appropriately?
Someone that would like to respond? So Dennis, since you raised that.
My response would be more that this is an aspirational thing, that it might be one way of trying to get at a solution that might otherwise be not very tractable. But for example, you talk about information, and certainly that's the case, that people talk about imperfect information and the fact that people don't know what they're doing, or at least don't realize the consequences, the full consequences of it. And perhaps through these ideas like sensors and so on, perhaps we can have better information and hopefully better decisions.
Anyone else would like to respond?
I mean, I guess I'd jump on, we had started getting into the economics of it, right? If you start pricing, since we as a country believe in capitalistic economics, right? We don't price the environment, we don't price water, we don't price many of those things in a way that actually balances its true value to us, right? So if water actually started costing what it should cost, if the cost of doing environmental damage was equivalent to what it would take to clean it up, and if all of that started to actually get integrated into the economy, I think it becomes less invisible, and you can weigh your decisions in a way that we're comfortable with now, as opposed to it being the invisible hand.
So David, I mean, you've worked on many projects over the years, so any favorites that involved an economic component that might shed light on this question?
Well, I was just thinking of the Gulf Coast aquifer system. Sorry, I just lost my microphone here. So the Gulf Coast aquifer system is a huge aquifer that runs from Texas all the way around to Florida and up the Mississippi River in Arkansas and Tennessee and so on. And the U.S. Geological Survey did a study of this, and they demonstrated that the current through flows of the Gulf Coast aquifer are 6 times what they were when it was a natural system. So in other words, what has happened is that the pumping that's going on all over that area is sucking down the level of the aquifer, which is sucking water out of the rivers. Eastern Arkansas, for example, is like a pincushion for irrigation wells. that are used to irrigate rice, and that water is being pulled out of the Mississippi River. So you've got, it's not a natural system at all. It's an industrially driven, forced system, and it's operating in a way that it never did under natural conditions. So we think of groundwater as the sort of thing that's down there beyond our reach almost, but there are some big systems that are already being really stressed out now and have been for a long time, actually.
Thank you. Maybe one last question or so here based on time. So one that we've not gotten into much, but I think this is an interesting one. So how might we think about balancing human and economic needs versus ecological needs? So we've talked about lots of other examples today, but I don't think we've sort of gotten into this one. And I know there are probably people in the room with a passion on protecting ecological systems. So Dennis, do you want to, let's work backwards on this one maybe, and let Dennis go first. And
that was unexpected. I think that there are, again, I go back to the idea of how can we best coordinate individual wishes, I guess, and reach some kind of global optimum. Unfortunately, I believe that the only sustainable option is probably some kind of a democratic thing, even though we may not like the outcome, and certainly in the recent past we may not have liked the outcome, but unfortunately I think that is the only sustainable option.
how we might balance human and economic needs with ecological needs?
I would say this is a very tough question. I mean, especially for a civil engineer. So, I would say, speaking of the human needs and speaking of the ecological needs, we probably shouldn't separate them into two conflict parties. Thinking about the ecology, the ecological environment, that's certainly part of the necessary environment we live in. It's not just for all the natural things, right? We as human beings, I mean, we must live in this world, and we coexist, hopefully in a harmonious way. So I would say it takes many years of work trying to figure out how we can actually balance the human needs and the ecological needs, and also putting in the ecological needs sort of relate back to how much our human needs is for the ecological environment.
We see ourselves as part of the ecosystem, then maybe thinking about balancing is not the right way to go about it. If we destroy our environment, if we say pollute our water resources, abstract everything so that there's no more water left, then we don't survive and we don't make economic progress. So they're not really two systems, they're one. So we see ourselves as part of that. How do we best make sure that our ecosystem is sustainable in the long term, and that is the way we assure ourselves that we'll be also able to meet our needs from that ecosystem over the long term. So it's not an easy thing to do. It's almost like a reverse way of thinking about the way things go from what we do. Maybe we think about we need this much water and whatever is left goes into the river, or we need to produce this. Well, too bad there's some sort of, some discharge into the water, but we then think of it, reverse is first we protect those resources, and then we are able to live within them.
Okay, I mean, I think it goes back to the economics I was bringing up before, but since I covered that before, I'll just throw out one more story. I'm going back to a meeting after this where we are in a discussion with stakeholders about how we're evaluating the effectiveness of a practice called drainage water recycling, where you capture what comes off of your field through the subsurface drains off the surface, put it in a pond, reapply it later. So looking at trying to use that as a water management strategy on the farm scale. But when you look at that economically, it costs a lot of money to build the pond. It requires lots of money invested in the irrigation and the pumping systems. There's not a cost, right? There's not a negative cost associated with what happens downstream necessarily from this process. And there are added benefits in that you can use the nutrients that are in the water that has run off and reapply it to your field. So you can also reduce some of the water quality impacts. But at this point, there's not an economic incentive until risk gets great enough on their crops. There's not an economic incentive for them to, in fact, install these methods in many places. And one of the other things we've gotten into, so a negative effect, is we were discussing the effect of crop insurance, in that in most cases the farmers don't need to mitigate the risk because they can pay into crop insurance that the U.S. government subsidizes, and they get, even when they have a bad year, when that system would help them mitigate the risk, they're going to get their full money back. So why invest in a practice like that? So there we have a disincentive to invest in, potentially, we're still studying, but potentially a disincentive to invest in something that would help.
Steve, David, thoughts on this challenging question?
If you think back to when the big rebalance happened in this country, it was around 1970. And the book by Rachel Carson came out. There was a debate, and then the Cayuga River in Cleveland or somewhere caught on fire. A combination of things happened. There was Earth Day, they had Earth Day, and the combination of those things led to the establishment of the EPA. Actually, it was established by President Nixon in 1970. You wouldn't think Nixon would be an EPA guy, but he was. And the key laws that preserve the ecology of the nation, the Clean Water Act, the Clean Air Act, and the Endangered Species Act, were all passed in like 2 years or 3 years after the establishment of the EPA in 1970. So the key rebalancing in terms of saving the ecology of the nation was all happened in a very short period of time, actually. And what's happened since that time is a working out of the details of how that, and modifications and so on. But there was a big shift happened right then. And so, I mean, it's hard to imagine there was a world without an EPA. Well, before 1970, there was no EPA. And so that was a deliberate action taken on the part of the nation to preserve their ecological integrity at the expense of just having a sort of a manifest destiny. You know, we have the right to rule over nature. That was the feeling before. We have the right to spread chemicals around, and it's okay. And then after that, there was a sort of a rebalancing. So I think that's a balance that has to be progressively shifted. I'm going on Monday to New Zealand. They had an election last fall. One of the key elections was about water quality issues. Was about water quality. And there's a feeling that intensified agriculture has polluted the nation's water systems to the point that it's no longer as pristine as people thought they should be. And they can't swim where they want to. There's endangered... there's algal blooms and so on where there just used to be fishing grounds. And there's a feeling like the whole balance needs to be shifted back. So there's a whole debate going on as to, okay, how do you achieve that? And the fact is they don't have yet a machinery like what was introduced with the Clean Water Act to achieve that goal. So now they're struggling with a perceived perception on the part of the population, which is largely urban, that their natural heritage has been diminished, but without a policy framework to fix it. And so that's one of the things I'm going to do, is to try to help how can we address those questions.
Well, I think we're past our appointed time. So thank you, panelists. Certainly enjoyed the dialogue. And yeah, let's thank our panelists.